Morning students. Today with the continuous lecture series of differential equation, we will continue the method for solve the differential equation of variable coefficient. Now we will discuss the new method to solve this type of equation, change independent variable method. In this method, like the name of this method, change independent variable. Here we replace or change the independent variable x in z form, and the linear equation is changed from x to z form. So then we get the solution of this type of equation. The objective of this type of equation, this is also a uh, strong tool to solve the differential equation of variable coefficient. So students will able to understand the one more method to find the complete solution of this type of equation. So we move to our lecture, and some in this topic we will discuss about the method, and then we take the example of this type of equation. So, I start. Let a differential equation let differential equation a linear differential equation where variable is action. Action. Let the equation d2y dx2 let the equation d2y dx2 plus p dy upon dx plus qy equal to. There are two variable x and y. X is the independent variable and y is the dependent. Now we change our independent variable x. So dy upon dz we will change x in z. So d2y dx2 we can write d2y dz square dz upon dx plus dy upon dz and d square z. Now putting this value, putting this value in given equation. So d2y dx2 tangent plus p dy upon dx is change plus q. Now we can write d2y plus d2z upon dx plus p dz upon dx dy dx plus qy is equal to. We can which is how we divide with dz upon dx. So so d1 is d2z upon d2z upon dx square plus p dz upon dx upon dz upon dx. q1 is equal to q upon dz upon dx whole square. R1 is equal to r upon dz upon dx. Okay, if we do not dz, if we do not dz upon dx is equal to z1 and d square z on dx square z equal to 10 p1 z2 plus dz1 upon z1 okay. q1 is equal to q z1 k r1 is equal to r. These are the three terms here. We have z1 is equal to dz upon dx and z2 is equal to d square z upon dx. Actually again I explain this is our standard equation, linear higher order differential equation. Here we have to change x in z. X in z. So we write dy upon dx is equal to dy upon dz and dz upon dx. Now, now we take d2y upon dx2. d2y dx2 we can write differentiate 1 again. We differentiate 1. We get d2y dx z square dz upon dx whole square plus is nothing dy upon dz d square z upon dx square. Now putting this value in this. These two values we put in the standard equation. So we get this by d2y upon dx whole square plus d2z upon dx square plus p dz upon dx dy dx plus 2y, which is, can be written as d2y upon dx2 plus p1 p dy upon dz plus 2y is equal to r. Now here P1 is the P2z upon dx2 plus P dz upon dx upon dz upon dx. Okay. Q1 is equal to here when we divide dz upon dx square. This is we divide all the equation by this, then this comes here, here and here. So we get P1, Q1 and R. P1, Q1 and R. Now P1 is equal to Z2 plus PZ1, where Z2 is equal to d square Z upon dx square, Z1 is equal to dz upon dx. Okay. So now we can see the example how to attempt this type of question. Like cos x d2y dx2 plus now we can write this equation nf dy upon dx cos square cos 1. Now now we apply the method of change in independent variable. Let new variable then now our new variable is z. So we replace x in z. So The equation 1 now becomes equation 1 become d2y dz square plus d2z dx square plus c dz upon dx 1 upon dz upon dx square dy upon z minus 2 cos kx dz upon dx का whole square upon 2 cos 4x upon okay. Now plus p1 d1 upon dz minus q1y is q1 plus q1 is equal to now by to the comparison p1 becomes d square z upon dx square plus p dz dx upon dz upon dx. Now we assume this is we make 0. For we make 0 this will be become d square z upon dx square is equal to minus p dz upon. So we can write this d square z upon dx square upon dz upon dx equal to minus. Both sides differentiate with respect to integration both sides. And p is equal to what is the value of p? 10x minus both sides integration. You dz upon dx is equal to log r. Here again rho dz upon dx we get positive and z is equal to we get again integration. इसका so we know the p1 is equal to t square z upon dx square plus p dz upon dx. We choose this type of dz z for that p1 becomes 0. So t square z upon dx is equal to minus p dz upon dx and this is do the integration become log dz upon dx is equal to log cos x and z is equal to we get sin x. Now q1 now q1 is equal to 2 upon dz upon dx equal to minus 2 cos square x upon z dz upon dx cos square is equal to cos square x. Cancel square out. And r1 is equal to r upon r. What is the value of r? Upon cos square x. 2 cos square. This is the value of Q1 R1 and T1 become 0. So now this value we put in the equation and we get the new equation with the coefficient constant. Okay. So here we find another form of linear differential equation where E1 is equal to 0, Q1 is equal to minus 2 and R1 is equal to 2 because then here we find another form of differential equation. Like if we count kx square plus c1 p1 is equal to 0, q1 is equal to minus 2 and r is put the value t2y plus 0 minus 2y to cos. This is equation. This is the equation. Now we can write this equation in form of if this is some variable is changed to z dz. Here dz also dz. Now we can write d square y dz square minus 2y is equal to 2 1 minus sin square x and psi square is sin square x z square minus 2y. We can put to 1 minus z. This is 1 minus z square. So here we can write d square minus 2 y to 1 minus. Now we first we calculate the CF. For CF We write the auxiliary equation. We write auxiliary equation is there m square minus 2 is equal to 0. So m is equal to plus minus 1. So Cf is equal to y is equal to C1 e की power under root 2z plus C2 e की power minus under root e की power minus under root 2z. Now this is our Cf. Now we calculate the Pi. Now we calculate. Now we calculate Pi. What is the value of Pi? Pi is equal to 1 upon Ft d square minus 2 1 minus. So here we take 1 upon 2 out, this become minus 1 minus d square by 1 minus this to cancel. This will be minus 1 minus d square by 2. Okay, now we can write 1 plus d square by 2 is to expand use the same order. So this is sufficient for expand. We can write 1 minus. Okay, now we take this inside 1 minus z square plus 1 by 2 t square 1 minus here minus 1 minus z square plus half d square become minus 2z and again differentiate and we get z minus 2. So this become minus 1 minus. So our Pi is come z square. Okay, Pi is come z square. Now our solution is our solution y बराबर Cf plus Pi. We have Cf is equal to C1 e की power under root 2z plus C2 e की power minus under root 2z plus z. This is our P. Now put the value of put z is equal to sin, because we put have the value of z is equal to sin x here. And here we get z is equal to z is equal to. So z is equal to sin. So y is equal to c1 e की power root 2 sin x plus c2 e की power minus sin x plus sin x. This is our solution. We put z is equal to sin x. Now again we see this example again. I explain again this example. Very important example in RT interaction technical university many times asked. Okay, student. We write this given differential equation in the form of linear differential equation. Okay. Now we change in this form. We put dy upon dz is equal to dy upon dx in the form of dy upon dz. Dy upon dx is equal to, we can take dy dz. So after the substitution we get this result. Okay. Now we have to remove this term p1. So we take this type of p, therefore p1 make 0. So we find out the value of z where p1 is equal to 0. So when we put 0, d square z upon dx square is equal to minus p dz upon dx. D square z upon dx square upon dz upon dx is equal to minus p is equal to 10. So we take the integration. Integration becomes log dz upon dx is equal to log of. Now dz upon dx, when cos x and z become sin. So z becomes sin. So q1 is equal to q upon dz upon dx का whole square. Q is equal to minus 2 cos square x, and dz upon dx is equal to cos square x. Cos square with cos square cancel become minus. Same r1 is equal to r upon dz upon dx square. Dz upon dx is cos x, so become 2 cos square. Now we find another form. This scale y dz scale plus p1 dy upon 0 p1 y is equal to r. This is the form. Now put the value. P1 is equal to 0, Q1 is equal to minus 2, and R1 is equal to 2 cos k. This is become our equation. This is the equation of constant coefficient. With constant coefficient. With constant coefficient. Now we know this type of equation solution. Cf plus Ki. The complete solution is Cf plus Ki. So we put d square y upon dz square minus 2y to 1 minus sin. So d2y upon dz square minus 2y is equal to 2 1 minus z square. D2y minus 2y is equal to 2 1 minus z square. Here we find the auxiliary equation. M is equal to we get plus minus under root 2. Cf is become C1 e की power under root 2z, C2 e की power minus under root. Now we calculate Pi. Pi is equal to 1 upon d square minus 2 because Fd is equal to d square and 2 is equal to 1 minus z square. We change in sin square z cos square z we can write cos square x we can write 1 minus sin square x, so sin square sin is sin x is equal to z, so we become 2 upon 1 minus z square. We make in the form of expand form. We take above and expand it. 1 minus d square upon 2 we can expand it, right? 1 plus d square by 2. So we take inside 1 minus z square, it become 1 minus z square plus 1 by 2 d square. Second derivative of 1 minus z square is minus 2. So it become only z. Here y is equal to become cf plus pi. Y is equal to cf plus pi. So this becomes cf value is c1 e की power under root 2z plus c2 e की power minus under root 2 z plus. So you can put z is equal to sin x. We get this is our. Now one question for assignment. This is your home assignment is 1 plus x square d2y dx square plus 1 plus x dy upon dx plus y 4 cos no 1. Same, the first we write in the linear form, where this becomes 1 upon 1 plus x dy upon dx plus 1 upon 1 plus x the whole square y is equal to 4 cos no 1 plus x. This is our equation. Now we again find this is p 1 plus x q is equal to 1 plus x the whole square and r is equal to 4 cos log 1 plus x upon whole. This is our. Now we change the variable in x to z and find p1, q1. Or change equation in the new form. New form is d square y dz square plus p1 dy upon dz plus q1 y. We write in this. Now we come to the our quiz. Today quiz. A differential equation of change in independent variable is change in independent variable is x changing to the a differential equation of change in independent variable is a method to solve the differential equation of variable coefficient, or in this we can change x in z. Okay, so we get a differential equation of change in independent variable is uh, solve choose to solve differential equation of variable coefficient. dy upon dx, then what is the value of y? Y become minus cos x. In normal form, normal reduction form, what is the value of I? We know that I is equal to q minus 1 upon 4 p square minus 1 upon 2 dp upon dx. This yesterday lecture we discussed about that. If p plus qx is equal to 0, then what is the solution? The solution is become y is equal to x. What is the value of q1? Q1 is equal to, today we see, when we divide upon dz upon dx the whole square, the q1 become q upon dz upon dx of whole. So today lecture we had more discussion about q1, p1, r1. So if you watch this lecture very carefully, you can reply all the questions very well. So thank you, students. Now we will move to the new lecture of method of variation, new concept for solve the differential equation.